Hello everyone. I am glad to share my recent research with you here. In this brief presentation, I will talk about the novel label refinement technique for enhancing adversarial robustness presented in this paper as self-guided label refinement, SGLR. Deep neural networks are shown to be vulnerable when the input data are slightly perturbed. In order to improve adversarial robustness, the most intuitive and effective approach is to incorporating these perturbed examples over the course of training. That is so-called adversarial training, which minimizes the worst-case loss within an epsilon neighborhood of the input space. However, AT suffers from robust overfitting. Look at the figure right hand. As the learning goes, the robust test error decrease at first, but eventually, the growing test error become the dominate, highlighting a significant generalization gap. Recent works show that robust overfitting is amplified by label noise. Under valid assumption about the bounded Hessian, we could know that perturbed set will include label noise with high probability. This also means that assigned labels of these adversarial examples should not simply be inherited from their clean counterparts. Previous work suggests that an adversarially trained teacher model could help rectify label mismatch. Nevertheless, the teacher model needs large consumption of computing resources. If we take the brief that AT attempts to exacerbate label noise in mind, why shouldn't we directly take noisy label learning into account during AT? Then, by using the lemma in noisy label learning, we derive the decomposition of cross-entropy loss function under Pack-Bayes framework. The noisy label will tend to provide positive value of mutual information about label given X and weight in models as the standard training goes. Then, we plot the mutual information about weights via taking some approximation to verify the wisdom when it comes to robust overfitting. The right figure sketches that the behavior of the IIW could be viewed as a characteristic of RO. Since the IIW play an important role in robust overfitting, could we mitigate RO via reducing IIW? We provide a theorem showing that for some type of mixed label distribution Y star, the IIW could be as less as its original version. This also suggests that we could take some label distribution interpolation to mitigate RO. To do so, we adopt the knowledge from model learned itself so as to guide the rectification of prediction probability. We also conducted extensive experiments to validate the effectiveness of SGLR. Our experiments shows that SGLR can simultaneously boost standard accuracy and robust performance across multiple benchmark datasets. Besides, as a plug-and-play framework, it is convenient for integrating with other defense methods. We also visualize the TSNE plot of learned representation under various label noise level. We found that self-guided soft label yield the most separable representation. In conclusion, first, we provide empirical and theoretical understanding on robust overfitting through the perspective of noisy label learning. Then, by reducing the information in weights, we proposed self-guided label refinement to obtain an informative label distribution. From the theorem, we hold the brief that it could reduce label distribution mismatch and thus alleviate robust overfitting. Our experiments show that SGLR achieves significantly improved clean and robust accuracy. That is all. Thanks for listening.